we will discuss the electronic record, selecting, installing, and maintenance of the EHR system. So the objectives of this slide series is to give you an overview of the electronic record system. We will discuss the Institute of Medicine's 6 aims for improving healthcare, what an EHR is, and how it has evolved. We will also outline the types of network elements an ERH system needs to function, as well as its typical hardware and software components. So why implement an EHR? Well, the Institute of Medicine, also referred to as the IOM, which is an independent organization which tries to help improve healthcare at the national level. They compiled a report in 2001 that stated the United States ranks 37th worldwide for quality of healthcare. In response to this, they compiled a report listing 13 recommendations designed to revamp the nation's healthcare system. One of the core recommendations was a call for a renewed effort on the part of the government and private sector to build an information infrastructure to support healthcare delivery, community health, quality measurement and improvement, public accountability, and improving research and clinical education. The Institute of Medicine's 6 aims for improving healthcare quality. The first one was to make the healthcare environment safer. Next was to make healthcare more effective. And then the third aim was to make healthcare more patient-centered. Get the patient more involved in the decision-making process. Help them understand their choices better. The fourth was to improve timeliness of healthcare services. The fifth was to make the process of providing healthcare efficient as a whole. And the last aim was toward eliminating disparities among diverse populations, making sure all patients have equal access to healthcare. So we have different definitions. According to the Computerized Patient Record Institute in 1991, they defined an electronic record as a set of components that form the mechanism by which patient records are created, used, stored, and retrieved. It's usually located within a healthcare provider setting. It includes people, data, rules, and procedures, processing and storage devices, and communication and support facilities. The federal government has defined a complete EHR system as containing 4 basic functions: computerized orders for prescriptions and other therapies, computerized orders for tests, reporting of test results, and physician notes. To date, however, no federally enforced single standard based on this definition has been reached. The Institute of Medicine also listed key capabilities that any EHR system should address. The first is that the system should provide a longitudinal collection of electronic health information, which means it follows the patient. The second is immediate electronic access to person and population level information. The third is provision of knowledge and decision support that enhances quality, safety, and efficiency of patient care. And the fourth is support of efficient processes for healthcare delivery. Several institutions attempted their own versions of the CPRs during the 1970s and 80s, but overall, successful implementation was quite difficult and rarely achieved. In the 1990s, computer technology was experiencing significant advances and processing power became more abundant. The IT industry began moving towards larger scale communication networks and distributed computing models, lifting many of the limitations seen in earlier CPR technology. Ambulatory clinics began utilizing EMRs during this time as well. However, despite software improvements, adoption rates were comparatively low. This was partly due to the rapid technological advancements in computer and software technology, which made EMR systems obsolete right out of the box. Usability issues often made adoption very difficult, especially for your smaller systems, smaller doctor's offices. By about 2000, PCs had low cost and there were lowered barriers for adopting electronic system with a sharp decline in startup costs. Today there's an abundance of inexpensive and extremely powerful computer systems available, making EHRs much cheaper. And they're better thanks to the adoption and evolution of graphical user interfaces, most commonly on the Windows platform. So it makes learning the electronic record system easier. Training costs are therefore reduced, along with networking of computers making updates and fixes a breeze to install compared to the older models. So the installation of an EHR system makes more sense than ever before now. So what's the difference between a CPR, an EMR, and an EHR? Well, the computerized patient record, or CPR, is a record system designed for use in acute care settings such as a hospital, where we generally think of an EMR as a simplified version of a CPR, used in an ambulatory care or physician practice. Lastly, an EHR is geared to provide a comprehensive healthcare record capable of moving with the patient. It's designed for interoperability on a regional or global level. Therefore, information can be shared among providers and systems. It is true that many legacy EHR systems have been slow to be adopted. A research study indicated a strong need for a more refined strategy by the industry to build more EHRs which don't force medical staff to change the way they practice medicine, but provides flexibility physicians need to solve real-world issues. Doctors tend to have illegible handwriting, which can often lead to inaccurate and costly data entry errors. With an EHR, the physician enters the data directly into the system interface, therefore dramatically reducing handwriting errors. With electronic records, massive amounts of data can now be stored digitally in a substantially smaller space, eliminating storage problems and virtually eliminated record search time. These efficiencies, combined with value-added software designed to minimize procedural and prescription errors, should over time improve overall patient safety in the healthcare environment. The ease of updating records while with the patient should also give more time devoted to physician-patient interaction. So with the EHR, we have the potential to decrease workplace inefficiency. It's expected that these cost reductions, combined with a reduction in patient care errors, should eventually result in lower malpractice premiums and litigation fees. Now we talk about hardware and software necessary for these systems. The hardware would be your computing devices that make up your system. Could be your desktop computers, laptops, servers, switchers, and routers. Software are the programs that make your system run. It tells your computer what to do and how to behave. Programmers develop this software by writing lines of programming code. This illustration shows prior to centralization of an EHR system, each organization or department maintained its own system and software designed to capture data specific to their specialty area. This meant there were multiple databases and patient records. The providers were required to open different applications for each department, so it was a very manual process. This illustration depicts the EHR system designed to receive data from each of these organizations' silos and compile them within a centralized database. EHR software is designed to compile the data in a more efficient manner, allowing the healthcare provider to access and cross-reference data from all available sources from one convenient client interface. This provides more effective patient care. Most of today's EHR systems use what we call a client-server model. This is a structure that separates tasks or workloads between what we call service providers, also known as servers, and service requesters, also called your clients. Usually a client computer and a server computer are two separate devices, each customized by their design purpose and communicating over a computer network. A server is a host that is running one or more server programs which shares its resources with clients. So the clients would be the users of the software. Here's an illustration of a client-server model. Using client-server architecture, it enables the roles and responsibilities of a computing system to be distributed throughout the network using several independent computers. All data is stored on the servers, which generally have far greater security controls than most clients. The data is stored centrally, making it easier to manage and update. So, in summary, we've learned about the electronic record, how it holds great promise for improving safety and efficiency in the healthcare setting. We also took a look at client-server model and how that is the best model to utilize electronic records. Thank you.